Die Roma
So I'll start with a little bit of background about myself. I grew up in India, where it's pretty normal to like maths and physics and science and so on. It's not one of those kind of slightly strange things, and I was one of the many people that loved science and maths. And then I moved over, so sorry, you can see me all ready to be an engineer, obviously from a very young age. I moved over to the UK to study my A-levels, where I did maths, physics, further maths, and design technology. But at the time, I was in a girls' school, and no one said to me that, well, you've got the perfect A-levels for engineering. So I didn't know what to do. I didn't have much advice about what I should do, and I loved physics, so I said, fine, I'll do a physics degree. So I applied, and I got into Oxford, and I was at St. Anne's College in 2001 to 2004. So unfortunately, Oxfest didn't exist while I was around, but it would have been such a wonderful thing to have while I was an undergraduate. So I started then to think about, well, what is it that I want to do after I finish my degree? So like a lot of you are probably doing, I started going to all these careers fairs, to the milk round, to all these different events that companies organize. And at the time, and I hope it's a bit better now, but at the time, there were only banks, law firms, accountancies, firms, and management consultants that were coming along to these fairs. And I was really uninspired by this. I was not the type of person to want to do a job just for the money. I wanted to use my maths and physics to do something interesting, and I just couldn't find what the answer was. Luckily, I applied to do a summer placement at the physics department in Oxford, and my job was to map out all the sprinklers and the fire extinguishers in the entire physics department. Okay, so not the most exciting job, but probably if any of you are studying physics and you have a safe journey out of the department, that's thanks to me, drawings that I did about 10 years ago. So obviously very important work. But the point is that I was surrounded by absolutely amazing mechanical engineers, and what they were doing was designing all these particle accelerators at CERN. And that's really when it hit me that engineering was such a wonderful combination of the maths and the physics, with working in the kind of corporate, possibly professional world, and being able to build real things. So that really excited me. And at that point, I decided to study structural engineering, so I did that at Imperial. I was the only person on the entire course that did not have an undergraduate engineering degree, so it was very tough, but I got through it. We're Oxford-driven people. And I got my first job after that, so I joined WSP about 8.5 years ago, and I've been working there as a structural engineer ever since. So what does a career in engineering actually look like? So I'll start with what it's not, okay? It's not lots of clever people spouting out difficult maths equations all day, which is what a young 16-year-old girl said to me she thought engineering was all about, and I quickly tried to dispel those myths. It's not a job where you can hide behind a computer and not talk to people. And it's not about playing with numbers in an abstract way with nothing real to show at the end of your day, which is sometimes how my husband describes his job in finance. But what is engineering? It's about using our experiences as people to understand what the problems are that humanity faces. It's about passionate people sharing ideas in a very collaborative way. It's about using creativity to solve problems and to achieve something tangible, something real, and something very, very rewarding at the end. So how many people do you know that can say that they contributed to the design of a space station, that they've designed a satellite, that they're solving our energy crisis, or perhaps a bit closer to home, something I'm more involved in, trying to ease the housing crisis in the UK? I want to use the Shard as an example. So as Lee mentioned, I worked on this project for about 6 years. I'm still working on it. It seems to never end, but never mind. And I spent about 6 years on the project. I designed the very base of the building. the foundations, and I designed the very top. So if anybody has been to the viewing gallery, all of the steel that you can see above your heads, I designed, which is very, very exciting. So I want to just spend about 5 minutes talking to you a little bit about a real-life example of engineering. So I'm not just standing here telling you how wonderful engineering is. Hopefully I just prove it to you with an example. So I want to talk to you about the basement. So this is what the basement of the Shard looks like. This is a SketchUp model from back in the day. This green sort of box in the middle of the building, how many engineers, structural engineers, civil engineers do we have in the audience today? Okay, that makes it easy for me. So the box in the middle of the building there is what we call the core. It's what gives the building its stability. So it's a bit like a tree trunk or your spine. So if you try and push the building over with wind, that's what keeps it nice and stable. And then you've got what we call a concrete raft, which is this big slab here. And that basically takes all the loads of the building coming down and then spreads it out onto all of these piles, which are concrete shafts that go into the ground. And then those piles carry the load into the soil. So it's very important for us to understand where loads go. We need to understand horizontal loads, which is from wind, and the vertical loads, just the weight of the building, all the people inside it, and so on. And we also have this, what we call a secant piled wall, which are interlinking piles. And the reason we do that is to create the basement. So it holds obviously all the earth out, but it also holds the water out because we've got quite a high water table in London. So that's what the basement looks like. Now, the big challenge we had was that we designed everything and we have to prove that it can be built safely, and we did that. But we now had to build this a lot quicker and more cheaply than we currently had programmed. In order to save the client some money, to give the contractors a bit more time. So normally what we do is we dig a big hole, put the foundations in, and then carry on up. But that just simply wasn't good enough for this case. So we came up with a method called top-down construction. Now, top-down construction is a method that's been used before on sort of small basements and kind of little projects, but it's never ever been done on this sort of scale. So it's possibly slightly scary, doing something never done before, but or exciting, the way you can see it. So the reason we call it top-down construction is that you start from ground level and you will work downwards and upwards at the same time. So this is what the site looks like. This is sort of a section through the site. And then these are the piles, the foundations from the building that we actually knocked down. So this is what we start off with. So the first thing we do is to start casting the ground floor slab concrete onto the ground. Sorry, I'll take that back. You start off by putting the new piles in, and they're all concrete, as I mentioned. Another thing that you do slightly unusually in this methodology is to put some steel columns in there, and I'll explain to you why we do that in a moment. Then you start casting the ground floor slab, and then you start to dig underneath it, okay? So now you can see why we have the steel columns. They support the ground floor slab, and at the same time, we set up what we call a slip form, which is basically a rig that you pour the concrete into to create that concrete core that I mentioned before. And it's a 24-hour process, so you keep raising up that rig slowly, and you do a floor a day. So by the time the rig's gone up, the concrete at the base has hardened enough to be stable. Okay, so that shoots off and starts building the core. So the interesting thing here is that we've now finished excavating down to basement level, but we still don't actually have the foundations complete. But at the same time, we have built a huge amount of that core. So we built up to 21 levels of what we call superstructure, so above ground, before we'd even completed the foundations. And then you finally come in, and then you pour the big thick slab underneath the core, and then you finish off the core, and then that's what the building sort of looks like in its final state. So these steel columns now no longer fulfill any function, but they were there sort of for the temporary case. So I've got some photographs. So that's what the site looked like after we knocked down Southwark Towers, which was the building there before. So it's a very, very busy, congested site. We used that rig, which I could talk about probably for another hour, because it was a very, very sophisticated piece of kit that installed our steel columns very, very vertically, because if they kind of leaned in either direction, they would poke out into the lift shafts of the building, and obviously that's not good. We don't want that. So these were rather large pieces of steel. They weighed about 1 ton per meter, so very, very heavy, quite exciting. So here you can see that we're starting to cast the ground floor slab. The piles have gone in. You can't really see them because they go in underground. And then we start to dig underneath that. And you can see the steel columns that I mentioned before now poking out. Okay, so I have another question for you, and you probably know the answer now because Lee briefly covered it earlier. So what percentage of engineers in the UK are women? I know that there's a lot of scientists here, but those are the options. So how many of you guess that A is the answer? Okay, B? Yeah, and C? So we're not a very optimistic audience here, are we? I had about 50-50, I think, for A and B. So the answer is A, which is, it's a terrible statistic, really. We're the worst in Europe in the UK. So not very impressive, really. For me, the biggest problem with this is, of course, diversity is important, and all of that is obviously very, very important. But the biggest problem is that we are not accessing our full talent pool. We need more engineers in the UK, and if we are not engaging half our population, well, then we need to do that, don't we, to get more engineers into the workforce. So I'm sure many of you are also finding that you're a minority on your course, but I say, well, does it matter? Because I see it as an opportunity for us as women to bring something slightly new and different and fresh to our professions in science, engineering, and technology. So these are 6 real women engineers. These are not actresses or models. And we mentioned Anne-Marie that I spoke with on the BBC about the lack of diversity in STEM. Debbie is from the US, and she's invented this toy called Goldie Blocks, which is for girls. I don't know if any of you have seen that. I've done lots of work with Victoria and Yewande, with Ellie, and then Belinda is one of our tech goddesses. She founded a company called Little Miss Geeks, so anybody that's interested in tech, please have a look at what she's been doing. So what does it mean to be in a minority? One of the things that I find is that people actually tend to remember you, so I will often be in a meeting, and this is not meant to put you off, but I will often be in a meeting where there's me and 19 other men. Okay, now what does that mean? That means that I can guarantee you they will remember me because I was the young female engineer in the room. They probably will forget the other 18 males in the room, but they won't forget me. So this gives me an opportunity to start to build relationships with the team, with the clients, with the project managers, and all these other people that I work with all the time. So I think relationships is quite an important thing to talk about. So you could have various types of relationships. You could have something a bit like that, or possibly something a bit better like that. So what am I talking about? Now I'm going to make some generalizations, so bear with me. I don't like making generalizations, but there are lots of studies that back this sort of thing that I'm going to talk about up, which is people say that women are naturally better at building relationships with people. So if you think a little bit about your friendships with men and women, you know, which of your friends show more vulnerability, can relate more closely to you, and can express their emotions, and perhaps build a longer lasting relationship. So just something to think about there. But how does this tie in with engineering? Because engineering is all about maths and physics, isn't it? It's a technical career. But I talked about engineering being creative, collaborative, and not a day goes by when I'm not on the phone to people in meetings, trying to win our next project, trying to work out with the architect how we're going to make a building stand up, working with mechanical engineers, electrical engineers to fit all of the services and projectors and everything in. So it is very important right at the start of your career, but I think as you get through your career, this ability to build relationships with people becomes more and more important. So an example I'll give you, which hopefully many of you will relate to, those of you who will be looking for jobs at some point soon, is that we're all going to have pretty good academic records, let's face it. That's great. That's going to get you a nice, strong CV, and that'll probably get you through the door for an interview. But what happens once you're through the door? All of that kind of, yes, it's a factor, but you're the person that's going to get you the job. It depends on how you influence your assessor. I interview people regularly for graduate positions at my company. And on the day, it's about the people that really strike a chord with me, that can explain their life decisions to me, tell me what they're passionate about, that inspire me and make me want to hire them. So it's not just the academic record that's going to get you far in your career. So I really encourage you all to practice in front of a mirror. And I know it's really embarrassing, but it works. And try and see how enthusiastic and passionate you come across when you talk. And if you're not coming across very passionate and enthusiastic, then dial it up a notch, and it might feel slightly strange, but it probably doesn't look as strange as you think it does. So I've talked a bit about all these wonderful things that we can bring to engineering, but what do we need to perhaps work on? So again, if you bear with me, I do tend to find a lot of women do identify with this, and in fact, I know you're doing a workshop on confidence and assertiveness later, so this actually ties in very well with that. So the imposter syndrome, okay, it's described as a phenomenon where despite all the external evidence of our competence or success, we just don't believe it, okay? We feel like we're frauds, that we don't deserve to be somewhere, or your success is down to luck or good timing, or something like that. You're deceiving people into thinking you're smarter than you are. And I can certainly relate to that and honestly say to you, when I first came into Oxford to study physics, I just came into the room and started talking to people, and I thought, oh my God, everyone here is so clever. What am I doing here? If I can get everyone to very honestly now put their hands up and tell us whether you've ever felt that way before. Okay, okay, hold that up. I want you all just look around you, okay? Because, okay, that's fine, you can put your hands down. Thanks very much for doing that. I want you to remember that vision that I think nearly every single person in this room put their hand up, okay? Because nearly 10 years into my career, when I'm given a new project, I look at the drawings and I go, oh my God, I've been working for nearly 10 years and I still don't know how to do my job properly. It never goes away. But what we can do is appreciate it, understand it, and try and work around it. So I then changed that to, I've been working for nearly 10 years. I know what to do. My buildings haven't fallen down yet. So that must be all right. Okay? So it is something that a lot of people feel. Who doesn't love a picture of some cats? So I want to talk a bit about confidence now, which obviously ties in very closely to what we've been saying. So here's a very confident-looking woman. There is, again, evidence to show that perhaps women struggle a little bit with confidence and the imposter syndrome a bit more than men do. So there's studies that show with MBAs, which are Masters in Business Administration, which are very popular for all these business leaders in the world. And what they were finding was that equally academically qualified men and women were scoring differently in their assessments, and the women were not doing as well. And why is that? That was because a lot of the assessment in an MBA is done on classroom participation. And so you require the confidence to stand up and use big body language to assert yourself and tell people that you know what you're talking about. And we weren't doing very well on that front. So there's a social psychologist called Amy Cuddy, and she has done a TED Talk, which I really encourage all of you to watch, because she talks about how we can use our body to influence our mind. And because we don't have a lot of time today, I'm not going to do this exercise with you, but I have done this in the past where I get basically all of the audience to stand up like this for 2 minutes, okay? And this is called a high power pose, or that is a high power pose. And really what this does, and there's scientific, we're all scientists, scientific backup to this, that when you stand like that, you increase the amount of testosterone in your body, male hormone, dominance, and you lower the amount of cortisol, which is your stress reaction hormone. And so actually, you feel calmer and more confident by just doing this simple exercise. So when you go for your next job interview, I don't suggest you do that in front of your interviewer, but Perhaps you go into the bathrooms just before and do a bit of power posing and psych yourself up. So why is all of this, why am I talking about all these things? Why is it important? It's very important if you come across confident and calm, and let's be very clear, I'm not talking about arrogance, I'm talking about self-confidence, okay? That you get to meet lots of people like today, okay? So my hint number one for you today is talk to as many people as you can, okay? You can get lots of questions answered if you've got questions for me later at the end of the lecture, or for any of the speakers later on for your panel discussions and so on. Put your hands up, be brave, ask questions. You get an answer for your questions if you're brave about things. It'll help you get your job, as I talked about, influencing, developing relationships in a confident way with your assessors. It'll help you to be effective in meetings. So again, imagine me with 19 men in a room. What is it that's going to get me through the day? It's confidence. Knowing that I'm well prepared, I know my stuff, and speaking up. And trust me, once you know what you're talking about, people listen to you. People are not out to put you down or anything like that. It's all with us to try and put it out there. It'll get you, hopefully, a good salary and package. Why do women get lower starting salaries than men? Because most men will negotiate, ask for more money when you apply for your jobs. It'll get you promotions. I realized one day that actually if I asked for a promotion, I might get it. And guess what I did? One day, it'll then make you an influential leader. And it'll make you happy, I expect, at the end of it. So I'm going to try and come up with some examples in my own career where, despite all of my natural, instinct not to do the following things, I thought, right, I'm going to do it and see what happens. So one of the examples is I got to work on the shard. My boss was assigned to it, so great, I get to work on the shard. But I said, hold on a second, how cool would it be to design the very top of the building? So for 4 years, I kept saying to my boss, I'm designing the top of the building. He was like, yeah, of course you are. Yeah, no, I'm really doing that. 4 years later, once we got to the top of the building, I did it. And now I get to tell people that I designed the top of the shard, so that's very exciting. I've applied for a number of awards, and why do I do that? Because I think it's great to have some validation of the work that you're doing. It's fantastic. But more importantly, I love to meet new and influential people. And by applying for awards, and I don't win all of them, trust me, I don't, but you get to meet a lot of people all over the industry, which is great. It's great to have contacts everywhere. And then being on the BBC with David Blunkett was slightly terrifying. So I was shepherded into the TV studio with 2 MPs and me. And politicians, trust me, they know how to talk. And I realized that if I want to get any of my views heard, I have about 3 minutes to speak up louder than the politicians and get my voice heard. And so while I was kind of live on camera, I was like, right, say something. And I did. And I'm really, really glad that I did that. So it's almost you have to think about what you would regret if you didn't do it, because that's invariably worse. So just to summarize, we've talked a bit about what an engineering career might look like, and this is just as relevant to scientific careers as well. We've said that they're creative. We don't tend to think of science, technology, and engineering as being creative professions, but I beg to differ. I think what we did on the shard was creative. We came up with a new way of solving a problem. You will be talking to people, working with people. I love that. I never wanted to have the kind of job where I'm just working by myself. And there is no feeling like looking at a paper that you've published or a project that you've built and saying that I did that. Having a real object or thing at the end of work is the most rewarding thing. So we talked a bit about real examples of engineering. We talked perhaps about women's ability to build relationships and influence people, and also that we may need to work a little bit on your confidence, and I'm very pleased that you're going to have an opportunity to do that later this afternoon. So I've got a few parting messages, and this is not because I'm some kind of clever person that knows more than you. These are things that other people have actually told me that I found that work, okay? So the first one is not to be afraid. So I've banged on about confidence and imposter syndrome, so hopefully that's quite self-explanatory to all of you. The second one is to have a mentor. It is really useful. I've got several mentors. Some of them I meet once a year, some of them I meet a bit more often. I've got mentors in my company and outside my company. And I find that when you start to question yourself a little bit, or you're not sure whether you're ready for the next promotion, or niggling little doubts like that, going to a mentor, going to a sounding board, somebody that can look at you in a very open, honest light is very helpful. And that's the thing that I think I gain most from having a mentor, is having an honest assessment of my skills and where I'm at and what I want to do. Sometimes they just ask really hard questions as well, which is quite good. Be confident, and if you're not confident, and it's taken me a long time to be able to come up and speak to people like this, you have to fake it, and it works, trust me. And the final one is to always push yourself. So if you're the type of person that wants to achieve things and do very well in your career and so on, then I think we need to make sure that we're never in a comfortable place. So the moment we feel, oh, we know how to do our jobs, it's all going swimmingly, smoothly, you need to find a more challenging situation to put yourself into, because that's the best way of learning new things. So thank you very much. I am on Twitter, and I've got a contact form on my website as well. So if anyone wants to get in touch with me, please do not hesitate at all. I might be slow in replying, but I do reply to everybody that writes to me. So thank you very, very much.